We have discussed the certain fundamentals about the MS 430. Okay, so we'll go ahead with that. Uh, so we have completed the addressing mode of MS 430s, and then now again we'll come back to the memory map. So this is a particular memory map for MSP 430F 5529 series, which is again popularly used in many applications. So, but any the concept is that the total memory is divided in different sections like peripheral, bootloader, then RAM is there, again flash, and suppose there is a USB, then we need the USB RAM is also there. So like that we can use it. And as far as the info memory is there, so user can use that for calibration purpose, or maybe some data we can preserve it. So that's why we can use it. Yeah. This is a simple comparison between two MSP 430 controllers, that is 5529 and FR 5969. So as I had mentioned, the difference between F series is nothing but it has only flash memory, whereas in FR means nothing but a flash RAM memory. Okay, so RAM is nothing but non-volatile memory. FRAM is nothing but a non-volatile memory. The purpose of this is the flash memory only contains the code memory, means we cannot modify the contents of the flash memory. But if you are using the FRAM, that is a flash RAM, so you can read and write. So though you can use FRAM like SRAM, which gives you up to 64 kilo more read and write storage. So in some of the applications, it is required that the huge data computation is there, and at that time, the user wants to read and write. For example, suppose I want to interface the TFT displays. So TFT display need a huge memory, displaying the characters, even images, and like that. So at that time, the this FRAM is very useful. The flash RAM is very useful. Okay, so that's the difference between the F series and FR series. So the only thing is that complete everything means there is no flash at all, so everything is there. FRAM, even the program is also stored in a FRAM, that is a flash RAM, and even the user data can be stored and read and write. Okay, we can. And another control is that on the fly I can modify certain part of my program, so that is called as in application programming. So that is also possible with the FRAM facility. Okay, so this again a comparison, means this slide shows how there is a difference between the flash and flash RAM. Okay, so it's again this differentiate about that, but rest of the things means if you go for the rest of the memory map, it is more or less similar. Okay, so at the bottom we have peripherals, then again we have bootloader, then again we have information RAM, then we have a normal RAM. Okay, so for the general purpose data storage and read write, so that we can use the RAM. USB RAM is there if suppose it has a on chip USB module. So that USB device is there, so you can easily treat your MS430 device as a USB storage or a keyboard or mouse, like that application also we can build around the USB module. So for that purpose we need a USB RAM. So again it's a special type. If the USB module is not there on a controller, then that RAM is not going to present. So like that way. And at the above the flash there is again interrupt vectors. So whenever the interrupt is generated, so we are going to map there that interrupts, and user has to write the interrupt service routine there in the interrupt vectors. Okay, so location. So like that way you can handle the interrupt vectors. Yeah, so this is a new feature is added in the microcontroller of the MS430. So there are very few controllers which give these facilities. Okay, as far as my knowledge is concerned, I have seen only MS430 till now. Okay, but I don't know about the any other controller who gives this support. But slowly, some controllers are giving this facility, non-volatile RAM, they're calling as that. So we can, there are number of, means 100 trillion read write cycles are possible with this FRAM, and write guarantee is there in case of power loss. So what means that, suppose we are writing certain data to the flash memory, obviously the writing takes certain time, and in between some there is a power, there is a irregularity in a power supply. So at that time they are giving guarantee that whatever byte you written a last before power failure, so that is clearly written on the memory. The another thing is that the memory rewrite cycles, that's timing required for the memory rewrite, is obviously faster, okay, compared to the normal RAM. Okay, so it's very faster, so 1,000 times faster than flash and even electrically eraser prom. This flash and electrically eraser prom requires more time for writing. Reading is not a problem. So you must have to select the RAM which requires lesser time for writing. That is again selection criteria, because generally reading is very same for any memory ICs, but writing is varying. Okay, so some RAM ICs give more, requires more time for the writing, some requires lesser time, like that way. That is a variation. So you have to select that. Then uh, this RAM also works on a low power, so it's nearly requires only 1.5 volt for writing and erasing. See, you can easily see that we are not bothering about the reading, we are bothering about the writing, because writing is critical for a memory ICs. So writing and erasing should be a very proper. Anyway, read, if you not properly read, you can read it again, but that's the condition, that how much time you require for writing and how much voltage or the current required for the writing. That's the important point. Okay? So that's the reason that why we can go for the FRAM. But the thing is that the cost of the IC with FRAM is obviously higher than only flash memory. Okay, because the memory is going to be costly. So you have to see that whether your application really need the flash RAM, then and then you select this flash RAM IC. Otherwise there is no need to select the flash RAM IC. Yeah, so this is just a comparison how flash RAM MCU delivers maximum benefits compared to any other controller. So non-volatile, we can able to retain the data though there is a power failure. So yes, that is not possible with SRAM. But if you go for the FRAM, then electrically erasable prom, that is EEPROM flash, so we can retain it. Writing speed, so writing speed is nearly 10 millisecond. For electrically erasable it's a 2 seconds, and flash is a 1 second. But SRAM is again more faster than the FRAM, it's surely there. Average active power, um, for FRAM, it's a moderate compared to the SRAM, but if you go for the comparison with the flash, is always less. So like that way, then writing cycles are so very higher compared to any other memory into this. Bitwise programmable, yeah, it is possible in the case of FRAM, but that is not possible in a EEPROM and flash. For SRAM and FRAM, it is possible. So unified memory, this again a new concept. Unified memory means the flexible code and data partition, means you can use any part of as a code, any part of the data memory. So that is a possibility is there in FRAM. Obviously, for the flash, that facility is not there, because we cannot use a flash for the data storage and reading, or rather data reading. And you can store the data, but you cannot write the data on the fly. So that's the way we cannot use the flash for data handling purpose. Okay, So this is the how the FRAM gives the flexibility. If suppose I'm using the flash technology only, so I have a limited RAM, okay, so maybe 6 KB, 2 KB, or like that, and that is fixed, so I cannot increase. But when I'm using the FRAM, that is a flash RAM, so I can partition that. I can decide how much part is used as a code memory, how much part I can use as a data memory. So there is always a flexibility. There is no need to suppose if earlier what's happened, suppose the RAM is going to be required more, then you have to externally interface the RAM. But with FRAM technology, so there is no need to go for the flash RAM. So that's why you can use the flash RAM. But consideration of this is a very important thing, is that the we have to cost matters, so you must have to check that also. Then thing is about the ultra low power. Okay, why ultra low power matters? So I think there is no need to tell about this thing. Okay, you can, everybody now knows that we want a portable device. You don't want to connect your device to AC lines, so we want to carry the device wherever you go. So that's why the wearable device comes in a picture now. So is required that 50 billion additional connected device expected by 2020. And whenever I'm saying that the connected devices, so what we mean by connected devices? Connected devices means the device are connected to the internet, that IoT devices, I say that. So they are going to be increased. Okay, so even 50 billion spent every year on battery. That means, see, when I'm saying that my device is a portable, obviously it's going to operate on the battery, and battery is going to be again costlier for me. Even I don't want to be charged oftenly. Suppose once it's charged, then it should run for hours, days, months, like that. So you must have to consider that the ultra low power is very important. And suppose I'm going to place the device in a remote location, in that case also I need ultra low power, and that is the importance here. In the case of MS430, just I had given a chance that for standby, that is LPM3. So I already mentioned there are 7 low power modes present in the MS430. So you can select any of the mode. So LPM3 is the third one. And if you look at the for the active, means when your processor or controller is active and it is executing the instruction, at that time it is consuming 170 microampere, but when you go in a standby, it is taking only zero point 0.4 microampere current. So that's the matter here. And another important thing is that the clock. Okay, so leave on the slow clock. Whenever you want to have a loop, there is always direct relationship. If your switching is a faster, you consume more power. Okay, and if your switching is slower, you consume less power. So it is always recommended that if it is not necessary to process the data at that faster rate, you can run your controller at the lower speed, a low power clock and peripherals. Okay, so and you can interrupt CPU only whenever there is need to process the data at the faster rate. Okay, so like that way also we can do that. On demand CPU clock, so this is another important thing. You can shut down the clock which is given to the processor, and whenever you require to wake up the processor, at that time only we are giving the clock. So that digitally controlled oscillator starts immediately whenever you trigger the DCO. Okay, so like that way, um, CPU processes data. So immediately once the CPU wake up, it processes the data, and again immediately after that, that data, once the data is handled to the peripheral, or maybe once it's sent to the your smartphone or a computer, then again it goes in a low power mode. Like that way, you can save much of the power. Okay. So as I mentioned, these are the various low power modes of the MSP 430. Uh, Active is the normal mode, so where the all the clocks are present. RAM retention is very good. Brownout reset is also there. Self backup is not required at all because it is always active, and by which interrupt sources is going in a backup mode, that also mentioned here. LPM 0, LPM 1, LPM 2. So that needs to have SM clock, auxiliary clock, like that. So you can choose any of the one clock. There are different clock sources are present in the MS430, so you can use any of the one clock source for that. So like that way, it is given. And when you are going in a LPM, LPM 0, LPM 1, and LPM 2, so the internal peripherals can make up your controller. Okay, the ADC, once the ADC conversion completed, then it wake up the CPU. Once the timer overflow, at that time also it wake up the CPU. So like that. And for serial communication, once you receive any byte from your laptop or maybe from your tablet, so at that time also it's wake up and it'll start functioning. But in the case of LPM 3.5 and LPM 4 and LPM 4.5, so the only external interrupt will wake up the controller. So depending upon what is the requirement, how we want to wake up your controller, on what occasion we want to wake up the controller, so you have to decide that, and you have to be in a position to select the a proper LPM mode. It is a responsibility of the user or the programmers that you must have to write a program such a way that if suppose nothing is going on, there is no need to process the data, and if your CPU is ideal, then you have to write an instruction such a that the CPU will go in a low power down mode. Okay, low power mode. And you have to take care of that when to wake up. So that should be again written in the program. So ultimately, whenever there is a wake up with these sources, so you have to take care of that, how to what to do after wake up. So like that way. So again, it's again a skill of programmer how to use this low power modes. They have provided it, but it is our skill set that how efficiently we can use this low power mode, and that's a matter a lot. So to do that means the MS430 given certain what they call as ULP advisor. Okay, so they are saying that maximum is the time in LPM 3. So what they recommended that, so try to use the low power mode 3. Okay, which is more reliable, which is more efficient. And another thing is that use interrupts to control the program flow. Means if suppose certain interrupt occurs, go in a slow sleep mode. If certain interrupt occurs, then try to wake up from that, like that. Okay, and replace the software with peripherals. This is again important thing that how we can manage the peripherals. Okay, uh, power manage external devices. So this is again a job of the designer, hardware designer, how we can manage the power which are connected with the devices which are interfaced to your MS430. For example, see, I've interfaced LCD. Okay, and suppose I'm not going to display anything and my CPU is idle. So at that time, you must have to take care that how to tackle the power required for the LCD. The much of the power required by the LCD is because of the backlight. So try to shut down the backlight. If we are not displaying anything on the LCD, so try to cut down the backlight. So that is again you have to take care from the software part. So generally what's happened, the backlight light is controlled through the transistor. If the transistor is on, the backlight is on. If the transistor is off, backlight is off. Like that way, you have to control. So that is a requirement. Even in the case of TFT, you take anyone. So whenever you are talking about the displays, the backlight takes a lot of the power. So if your machine, your system is going to be in a standby mode, so try to cut down the supply of the your TFTs. Okay. Then how to configure the unused pins. See, it's not the case that every pin we are going to use for your application. It may possible that out of 40 pins we are using only 30 or 32, and remaining 8 GPIOs we are not using it. So at that time you must have to configure it properly, as input should not be as output, because when you send that output the leakage current is more. So like that way, even efficient code, as I said, the MSP for 430, or other Texas, has given you all the facilities of the low power modes, but it is up to the programmer or developer that how efficiently we can use it, that low power modes, by writing the efficient code. This is a very important. Okay. Then even wall power devices can be a greener, means what it means is that you can consume less power. Okay. So there is a utility present by the MS4 by the Texas, that is called as a ULP advisor, that is ultra low power advisor. So they will give the some guidelines. Even looking at the code also, they will mention, they will check out that. Okay. So what are that guidelines? They'll ask you to LPM use, then instead of flag pooling, they want to use it use ISRs, interrupt service routine, then terminate the GPIOs which is not being used by the system. So like that, so they will give us guidelines how we can write the programs, and if you just follow that guidelines also efficiently, we are able to utilize the battery power. So there is a software called as the ULP advisor software. Okay, so turning, so this will give a guidelines. So ULP advisor analyze all the C code line by line. Okay, and they will give guidelines. Okay, can you replace this code with this, like that way? So they will give suggestions, so they'll not change. Okay, so they will give a suggestion, and even they will estimate how much power is being consumed by your code, like that way. They will estimate, and they will also identify the areas which can be improved, and identify the key areas of the improvement. So they will give the uh, certain areas, certain code things, and they will ask you to simplify or use some alternative method for writing the same code, so that we can modify it. Okay, and once you modify it again, you analyze the code for the ULP, and if you satisfactorily get the results, then use that code for deployment. So like that way, they will guide you. Okay, so about that. So slowly we're going to be expertise in the low power utilization. Okay. So this is about the simple architecture about of MS430. So if you have any doubts related with the architectures or anything else, so we'll have a discussion. Otherwise, I'll go for the peripherals of the MS430. Anybody has any doubts related to the MS430? The another important feature of any controller, that is called as GPIOs. We are going to interface the a lot of the devices using the general purpose input output port. Okay, so there are number of GPIOs are there. There is confusion, means they port 1, port 2 up to port 8 are present in the MS430, depending upon which type of the controller we are using, depending upon what you say that mm, how many pins are there for that IC. If it is a 14 pin IC, then there are only two ports are there, that is port 1 and port 2. If there is a 28 pin, then maybe increase. So like that way, the number of ports are increased with the number of uh, IC pins, like that. Okay, so you can go through your data sheet, whichever the data sheet whichever the IC you selected. So refer the data sheet. Rather, instead of data sheet, I'll call you as a technical reference manual. So you refer the technical reference manual of that particular device, and that will give complete insight about the controller. Okay, so this diagram shows a very general thing here. You can program each and in as an input output. Okay, you can another important feature is that every port pin act as an interrupt. Okay, so that also can be configured. So you can configure as the input or as output or as an interrupt, and are multiplexed with a special function. For example, some port pins are multiplexed as a I2C lines, that is SCL and SDA. Some are for the SPI communication, some are for timer inputs, some are for serial communication, some are for as a capture input, some are acting as a PWM output, so like that. So you have to configure it. Okay, so these are the features. So we can able to independently program the individualized IOs for functionality, whether you want to use as input or output. You can decide any combination of input or output. It's always important that you must have to configure the port pin first and then use it. Okay, so you are able to configure as a port pin interrupts also. This is a new feature which is coming up nowadays. Most of the controllers are giving this facility. So every pin act as an interrupt pin. uh, then there are independent input output data registers are there. So whenever you want to read something, then you have to use a different register. Whenever you want to write something, you have to use a different register. So like that way, you can configure as pull up registers, pull up and pull down. So that is also possible. Internal pull down, pull up, we can configure it. Then you can also configure the pin oscillator function. So this is a very rarely used, but for us, input output combination and a special function is important. So as I said, you must not configure the IO first. Before you want to use it, you must configure it. The very important thing is that first of all, you have to select the function, whether you want to use that port pin as a GPU pin, that is simple input output pin, or any peripheral thing. For example, whether you want to use as a UART pin or SPI pin, like that. So that should be told. So this is again depends on a data sheet. So you have to refer the data sheet of your the selected controller. There are most of the pins are multiplexed with a special function, at least one or two. Okay, so either it may act as a GPIO, it may act as a first alternative function or second alternative function. So using this pin select registers, you can configure that port pin as a uh, GPIO pin or as a first alternative or second alternative function. So like that way you have to select that. Once you selected that as a GPIO, okay, then you have to set as a direction. So whether you want to use as input pin or as output pin. So if you are making that corresponding bit in port direction, see px means nothing but I can write p1 direction or p2 direction, like that. So corresponding x replaces with the corresponding port number. I can write p1 direction, p2 direction, p3 direction, like that. So p1 is nothing but port 1, p2 is nothing but port 2. So like that way. And each bit in that port pin corresponds to the port pin. Okay, so bit 0 in the p1 direction corresponds to the p1 dot 0, that means first pin of the port. So like that way, and if that bit is 0, then it is as an input, and if that bit is 1, it is output. By default, every port pin is an input. Okay, by default every port pin is an input. So this is again obviously why port pin as a input, again to save power and to accidentally switch on any output device. So that's why by default each and every port pin is as an input. Then you can have a enable the pull up pull down registers. So there is a SFR is there, that is a PX REN. So P1 like P1 REN, P2 REN like that. So you can use any one for configuration of your digital IO GPIO. Okay, so are very important for configuration of GPIO. And then you can use the input register for reading purpose. Okay, so each bit in each PX in, that is P1 in register, reflects the value of that input signal. And you can use the P1 out, P2 out like that as output registers. So if you want to write something on that port pin, then you can use this P1 out or P1 in register. Okay, so like that we can use it. It's normally there. So those who are very much familiar, there we don't have this SFRs or registers who will select as input and output, configure as input output. No, but nowadays every risk based microcontroller, if you take even AVR, even if you take PIC controllers, this facility is there. Okay, so you have to select the first direction of that port pin, whether it's as input or output, and then you have to use the corresponding SFR for reading and writing. So like that way, it's a very general now, and similar pattern they have used in a MSP 430. So given a certain example how we can use it, for example, suppose I want to use P1.4 and P1.7, that is higher nibble as the output and lower nibble of the port 1 as input, then I can simply write P1 direction equal to 0x F0. So this means higher nibble of port 1 becomes the output and lower nibbles become the input. Okay, if you want to enable the uh, pull-ups on port pins, then simply make the corresponding port pin as a 1. So here we have made port, that input ports, as a internal pull-up. So P1.0 to P1.3, so we have made as a internal pull-up. So we write 0x0f like that. Then so you can use a P1 out for writing something on a port pin. Okay, so for example, I want to make only port pin P1.4 and P1.16 as a 1, logic 1, then I'm writing simply 050. So this will make that corresponding pin 1. Okay, it's again a skill set of the programmer. So you have to use the AND operation or operation to selectively clear, to selectively set the corresponding port pins. Okay, and if you want to read the pins, then simply we can use P1 in SFRs for reading the corresponding SF port pin. So like that way you can use. So whenever you want to handle the any GPIOs, so we need mainly we need P1 direction, P1 out, and P1 in, like okay, corresponding out register and input register and direction register. If you want to use as special function register, then we need selection, peripheral selection register. And if you want internal pull-ups, then at that time we need register enable uh, SFR. Okay, so this is about the GPIOs. Okay, so this is, gives the mapping. So for understanding purpose, I have only given the port 1 SFRs. Similarly, the SFRs will be there for port 2, port 3, port 4, up to port 8. Now we have discussed the only direction register, output register, input register, but we have not discussed about the interrupt. So whenever we want to enable the any particular pin as an interrupt, then we need to use a interrupt enable SFR of the port 1. Then we must have to set whether we want to detect the rising edge on event or falling edge event. So that must be there in a interrupt a select. So corresponding pin will be there. If it is low, it's a low falling edge. If it is 1, it's a rising edge. Like that way you have to select. Then the interrupt flag. So whenever the interrupt occurs, the interrupt flag will be set. Okay, and this interflag will enable the interrupt of the port input, provided provided you have enabled the interrupts of the MS430. If you are not enabled the interrupts of the MS430, the only this bit is going to be set, and user has to poll that bit whether the interrupt occurred or not, whether that event is generated occurred or not. If event occurred, then you have to do the certain action. So the interrupt flag will decide when to generate the interrupt. Okay, and interrupt flag is set whenever there is event on that port pin if you are enabled it. Okay. Then the timer. So there are a variety of the timers are there. So we can categorize as timer A, timer B, timer D. So each has different facilities, but more or less all these timers are same. Again, when I'm talking about the timer A, there timer is the so at that time we calling as a timer A0, timer A1, timer A2, and if you go for the timer B, then it may be timer B0, B1 like that. Okay. Apart from these timers, which are acting as a timer counters, okay, either we can use as a timer, either we as a counter, and also there is a capture compare facilities there. Even we can generate the PWM signal on these port pins. Okay, so there are certain port pins are there which acting as a PWM output. So we have to configure it first, and then we use a particular timer. Uh, uh, Another thing is that apart from these timers, there are water timer and real-time clock. Real-time clock is not the requirement that every controller has that. So RTC is present in a very particular range of the ICs. So it is not present in every IC. So that is one case. Obviously, the watchdog timer is there. So depending upon what type of the controller we are selecting for your application, so the